looking at this one, and I'm thinking this for this problem, the integrand is, I'll write it as a function, f of x or f of t, I guess I'll change that. F of t is e to the square root of t times the sine of t. And I don't know what the graph looks like. I don't really need to know what the graph looks like. I do need to know the formula for the trapezoidal rule, and I need to be able to figure out some y values for this problem. Figure out the x values as well. So here's my trapezoidal. I write t sub 8, and there I'm using the notation of the author of the book with this means the sum of the 8 trapezoids. So it's going to equal delta x over 2, and then I kind of like to use brackets right there, and this will be f, well, I'm using x, but on this problem it's really what? T. Let's see if I can make that adjustment. T. So this one is f at t sub 0 plus 2 times f at t sub 1 plus 2 times f at t sub 2 plus 2 times f of t sub 3 plus 2 times f at t sub 4 plus 2 times f at t sub 5 plus 2 times f at t sub 6 plus 2 times f at t sub 7 plus the last one stands by itself, that's f at t sub 8. So there's the formula, and what I have found to be helpful is to do a number line and a portion of a number line. It's not the entire number line. So I have this segment, and I'm going from 0 to 4. And I got those from where? From those endpoints, the limits of integration. See, right in the middle, that's 2. This is 1. I've divided this up into 4 pieces, but I need how many? 8. So let's go ahead and say that's 1/2, 3/2, 5/2, and 7/2. These values I've put on this number line, these are values for t. And in fact, 0, that is the t sub 0. 1/2 is t sub 1. 1 is t sub 2. 3/2 is t sub 3. 2 is t sub 4. 5/2 is t sub 5. 3 is t sub 6. 7/2 is t sub 7. 4 is t sub 8. Then I need to calculate the function value at each of those numbers. So this would be f at t, and the first one here would be e to the square root of 0 times the sine of 0. What is e to the 0? 1. And what's the sine of 0? 0. That's 1 times 0. That's going to equal 0. And then the next one, this would be e to the square root of 1/2 And then that's the sine of 1/2. And if you like, write it as 0.5. The next one, that's e to the square root of 1 times the sine of 1. And then this is e to the square root of 3/2 times the sine of 3/2. This one is e to the square root of 2 times the sine of 2. E to the square root of 5/2 times the sine of 5/2. E to the square root of 3 times the sine of 3. E to the square root of 7/2 times the sine of 7/2. And then e to the square root of 4 times the sine of 4. In fact, square root of 4, that's 2, so e squared times the sine of 4. So we'll plug all that into the formula up here. By the way, what is delta t? That's 1/2. There is a little formula in the book for finding delta x or delta t, but you can look right here. This is, delta t is, what is the distance from one endpoint to the other right here? That's 1/2 on all of them. So for my problem, I'm going to end up with t sub 8, delta t is 1/2, that's 1/2 over 2, so that'll reduce to 1/4. But maybe I don't want to reduce it. Okay, I'm going to have 0 from right here plus 2 times e to the square root of 0.5 times the sine of 0.5 plus 2 times e. Okay, this is the square root of 1, that's 1. So that's times the sine of 1. Plus 2 times e to the square root of 3/2 times the sine of 3/2. And if you want 1.5 plus 2 times e to the square root of 2 times the sine of 2 plus 2 times e, this time I'm going to try to remember, let's go with the decimal, square root of 2.5 times the sine of 2.5 plus 2 times e to the square root of 3 times the sine of 3 plus 2 times e to the square root of 3.5 times the sine of 3.5. This last one, that's going to be e squared, and on this one you don't have the 2 in the front. Here, I'm going to put 4 in parentheses. So have to plug this into your calculator. You might find some shortcut ways you could, shortcuts you could take, like maybe all of these that are multiplied by 2, maybe I want to factor that 2 out. And that's going to impact this 1/4 a little bit, but might be a little bit quicker to do that. You have to be careful, this one is not multiplied by 2. Okay. I have this decimal approximation for it. I'm not going to take the class time to check this. Although if I was plugging this in my calculator, what do I have to make sure of? That it's in radians. If you're in doubt, go with radians.